Hello everyone, welcome to the course of HDL Digital Circuit Design. Today's topic is level of abstraction in Verilog. Myself Shilpa Rudravar, Assistant Professor, School of ENTC Engineering, MIT Academy of Engineering, Anandi Pune. So moving ahead with the today's topic. So Verilog. In previous lecture, we have seen what is meant by HDL, that is hardware description language, and there are common HDLs are available, that is Verilog, VHDL, and System Verilog, which we are focusing on Verilog HDL. So Verilog is normally used in industry. As I told you, HDL stands for hardware description language, and it is used to model the digital circuit. Now, whenever we are writing code in Verilog, basic thing you need to remember that there is a module and end module. Within that, you need to write your code. A structure. So basic unit is module. Inside the module, you are describing the functionality. First you are writing input, output, in-out ports, then functionality, and then end module. So example is a computer. So functionality wise, it performs various computations, and for that input ports and output ports are available. So we can consider keyboard as an input port, mouse as an input port, monitor and printer as an output port. So how to go ahead with the Verilog. Now here you are able to see the structure. So first is the interface. So whenever you want to interface, ports should be available so that you can interface it with the outside world. So ports means input, output, in-out pins available. Now over here on the right hand side you are able to see module, which is the keyword, and end module is another keyword. I already told you all the keywords that are the specially reserved word which is having its meaning, and that is known by Verilog. So these keywords always will be there in the small case. So Verilog is the case sensitive. All the keywords you need to use over here in the small case. Next thing is that module name. You need to write anything, whatever the name you want to give, it should not be keyword. And inside that you need to use the port list. That is, if AND gate is there, to input AND gate, A, B are the input and C is the output. That way you will be writing over here A, B, C, and semicolon that indicates end of the line. Again, whenever you are using module name, it should not be starting with digit. It should not start with special letters. You need to start it with the character. So here I can give the name as a AND G, A N D G, if I need to write a code of AND gate, because if I am writing AND only, then it is a keyword, so it will not be proper. So it will be giving you error. So that way, other than keyword, you can give any name, or AND underscore 2 also you can give. After that you need to declare which ports are there and which are the input ports and output ports, because inside this we have written A, B, C. So that will not be clear key which is A, which is B, that is input or output, and that's why you need to declare over here. So I'll be declaring input A, B, output C. Parameter declaration will be happening over here, that if you want to declare some variable, some registers over there, so that you can be declaring over here. After that, body you need to write, that is internal part of module. The functionality you will be defining over here. So what is meant by functionality? At this point you will not be knowing what is the relation between A, B and C, but that functionality, that is relationship between A, B with C, will be declared over here. That is called as a functionality, and that you will be writing like C equal to A and B, and ending with the end module. So this is the overall structure of your Verilog code. For example, the code for full adder is given over here. As you know that full adder is having sum and carry as an output and A, B, C in as an input. So same thing is mentioned over here. Module, which is a keyword which is written in the pink color, and whatever are the keyword that is written in the blue color. So module are the keyword, and whatever is the identifier that is written in the blue color. So identifier means the name given to your variable, module name, that is the identifier. It should not be same as a keyword. Module, that is the keyword which need to write in small case. The name of module is written as a adder because it is not a keyword. You can give it in bracket. You are having carry, sum, A, B, C in bracket complete semicolon. That is the end of line. Now here it is not specified whether carry, sum are the inputs or output, and that's why you need to specify it over here. So output, that is the keyword again, carry, sum, as these are single bit, that's why both are of same type, data types are same. So that's why we can write it by separating it by comma. Otherwise you can write output carry semicolon, output sum semicolon, that is also possible. Input A comma B comma C in, again semicolon, because all are of type 1 bit data, and that's why it is separated by a comma. After that, this port declaration has been done, you need to write the functionality, because how carry sum are related to the A, B, C in, that you need to specify. So I am writing this code in behavioral model data flow modeling style. So you need to use keyword assign. Now there are two outputs, carry and sum. So here concatenation operator is used, which is denoted by the symbol. So carry comma sum. So first bit will be of carry and second bit will be of sum, that will get concatenated. So instead of getting separate bit, you will be getting carry and sum combiningly, equal to A plus B plus C in. Meaning of that, if I want to perform full adder operation, I'll be getting sum and carry after adding A, B, C in. So that's why it is written as A plus B plus C in. And end module, that is the end of this module. So this is the code of Verilog. In this way you need to write. We will be moving ahead with the level of abstraction in Verilog. That you can write a Verilog code in different modeling style, that is called as the abstraction level. First is the behavioral level, second is RTL, that is the data flow, and third is gate level. So depending upon how you are writing a code, you will be writing that in this modeling style. So first we will be moving ahead with the behavioral modeling style. Here you are able to see this particular modeling style focuses on the algorithm. The behavior is implemented in terms of algorithm and functionality. So what are the description? Means whenever you are writing this particular code in behavioral level, high level algorithms are used and state machines normally are written in the behavioral modeling style. Here which constructs you need to use? You can use initial, that is again a keyword, always, if, else, case statement, loop, while, because in previous lecture I already told you, whenever you are writing something inside the always, that are the sequential statements, and case, if, else, for, while, these are the sequential statements. If you are writing two always block over here, the two always block execute concurrently, that is parallelly, but whatever written inside this block execute sequentially, one by one. So always, whenever you are using behavioral modeling style, you need to use this keyword as a always, at. So what is the way to write a code in behavioral? Suppose we need to implement code for full adder, which I have explained in earlier PPT. So module is the keyword, you are able to see that is in pink. Then adder is the name given to that particular module. It is identifier. Inputs are A, B, C in, and output are carry and sum. So you are able to see this carry comma sum comma A comma B comma C, bracket complete and semicolon. Now to define which is input and which are output. So output is again a keyword, input is again a keyword, and you have defined this carry sum as a output and A comma B comma C in as a input. Now in behavioral modeling style, all output you need to define as a data type reg. That is, reg is the key data type which will be holding a data. It is ability to hold the data. By default they are wire data type, but in behavioral output you need to specify as a reg data type. So sum and carry are output, so they are defined as a reg data type. Now in behavioral, everything you will be writing inside the always loop, that is always block. So keyword is always at. In front of that you will be writing sensitivity list. Meaning of sensitivity list is that whenever there is an event on this parameter, your output is going to change. Event means whenever the A is changing from 0 to 1 or 1 to 0, it is event. So if it is changing from 0 to 0, that is not called as an event. So meaning of event is that whenever there is a change in data from 0 to 1 or 1 to 0 of any of this variable, that is A or B or C, your output is going to affect. So you need to write that many input that are affecting your output inside this bracket, that is called a sensitivity list, and you need to separate it by or. So A or B or C in, that are the input which are affecting your output carry and sum. So this is the concatenation operator, that is over here symbol you are able to see. So carry comma sum, these are getting concatenated and you will be getting 2 bit, that is 10 or 01, whatever the sum and carry you are having, instead of getting single bit. equal to a plus b plus c in, means addition of a, b and c in you will be getting in the carry and sum in terms of 2 bits because you have done the concatenation, and this is the end of module. This is not the only way to write a code in the behavioral modeling style. Instead of this, you can use case statement, if else statement inside the always. So always block execute parallelly, but whatever written inside the block execute sequentially. So this is the behavioral modeling style. Moving ahead with the RTL, it is also called as a data flow modeling style. It is like a flow of data. Whenever equation you are getting, Boolean equation you are getting, so it is indicating how the data is flowing from register after performing the operation. So same is explained over here. In the data flow modeling style, you are using keyword like assign over there. Always blocks execute parallelly. So 2 blocks are there that will be executing parallelly, but whatever written inside that will be executing sequentially. So over here you are not using always block, but as 2 always block execute parallelly, so that's why it is written. So in this, statements execute concurrently, that is parallelly, and that's why case statement, if else statement, that can't be used in the data flow modeling style, that is RTL modeling style. So how to write a code? So same thing, you are able to see that module is written, name is written, input outputs are mentioned, they are separately mentioned whether it is input or output. Here main thing is that keyword assign. So this is the assign keyword which is you need to use in data flow modeling style. In previous you have used always add and sensitivity list. Inside that you have written sequential statements, but here you have to use concurrent statement and you need to use keyword assign. Again concatenation operator and this a plus b plus c in. So difference between two modeling style you have seen. Assign keyword is used in RTL and always add sensitivity list is used in behavioral modeling style. Or you can use case statement, if else statement inside the always block in the behavioral modeling style. And end of the model, that ends your Verilog code. So this is RTL, that is data flow modeling style. Here you should be knowing equation, Boolean expression for writing a code in RTL. Moving ahead with the level of abstraction, gate level. So here modular structure should be known to you, gate level implementation should be known to you, then and only then you will be able to write a Verilog code in gate level. Now here for this construct you will be using at a primitive, that is gate. So and or not, here you are able to see these are the gate primitives. This is the small function already written in the Verilog stating the meaning. So this is what is the and. You need not have to mention that a and b equal to c. So it will be knowing what is the meaning of and that is the gate primitive. There are total 8 gate primitives present in the Verilog. So other than that there are 12 primitives are there. In the coming session we'll be addressing that. So as I told you, for writing a gate level modeling style, that is Verilog code, you should be knowing that gate level structure, then and only then you will be able to model it. So here, as you know, whenever you are solving equation for full adder, you will be getting something like that, ki sum equal to a XOR b XOR c. So here same is mentioned, diagram related to that XOR gate is there, a b c in are the input and you will be getting sum. And for carry the structure is like this, a and b or a and c or b and c in. This is what is the carry. So this structure is known to you. If that is with you, you'll be able to write a code. Now how to write? Again module, end module, in between that you need to write. Up to this it will be same, input you need to specify, output you need to specify. Now something is there coming as a wire. Now whatever is not accessible, because a, b, c in, these are accessible from the output. Sum and carry you are able to observe, but internal signals, connections you are not able to see, and that is not mentioned inside your port, and that you need to define as a wire. So this is the signal connecting or wire connecting two components. So that you need to mention. So wire W0, W1, W2, that is mentioned over here. Now once that has been done, now you need to port map it. You need to connect output of this to the input of this. Input you need to connect here. That way connection used to make. So you need to do port mapping, and for that you need to write that primitive. So over here we are having first component, second component, third component, fourth component and fifth component. So first name is given as a U0, U1, U2, U3, U4. That is instance name or the component name you can say. Now, as this is the XOR gate, so you will be using XOR primitive. So XOR, you need to write that instance name, that is U0. I am writing this for this U0 because there might be two XOR gate present. Instead of over here, you are having two AND gate. So how to differentiate which AND gate that is? So name is different, U1 and U2. Here XOR is there, so instance is given. Inside the bracket, what you need to do? XOR gate is having 3 input and 1 output. So you need to write output first. This thing you need to keep in mind. So output is what? Sum. So we have written comma. What are the input? A, B, C. That is there in the port. So we have written output first, then separated by comma inputs. A, comma, B, comma, C, because it is having 3 input, 1 output. Next instance is U1, which is the AND gate. There are 3 AND gates. It is separated. It is differentiated by instance name U1, U2, U3. So first AND is written, instance is U1, so I am writing for this. So W0, that is the output first you need to write, so that is wire W0, we have mentioned it over here, and AB, so that is mentioned over here. Next, second instance is U2, that is again a AND gate, so you will be writing AND U2, output you need to write first, so W1, inputs are B and C. So here there is a mistake. Instead of that, they have written B, C in for this, and output is W. So you need to write W2, or that way you can make the changes. So if you are writing related to this U2, you will be writing W1 A comma C in. So W1 A comma C in. Here should be correction, that is A. Here for U3, you are having output as a W2, so you have written output W2. Next inputs are B and C in. So instead of B over here, this is proper, just you need to make the changes in A. And lastly, you are having XOR gate, which is having 3 input, 1 output. So output you need to write first, that is carry, and then followed by the input, that is W0, W1, W2. So that way this is showing the port map, that how that gates are linked with each other, and AND module. So this is the gate level modeling style, where you need to define the connection between this component, and you need to use gate primitives. So hope the things are clear how to write a code in different modeling style. So I am ending here with the different modeling style and its coding example I have explained. So thank you and happy learning.